Thanks again for waiting. So now my intent, I'll be talking, which is easy. So my intent is essentially to wrap what Cass said and what we heard from Sanders into what it means from an IoT viewpoint. We heard about the features, we heard about the functionality, but why is it important for IoT is critical. So I will talk through that. This is not as technical as the previous presenters. This is to give you a path forward. I know there are a lot of people in the room who are thinking about products, definitions, and what to do with removable secure storage going forward. And that's what I'll be talking about. Again, for those who are late into the room, my name is Vamshi Kandala, the VPGM for Granite River Labs. We are a test automation services company based in Santa Clara with multiple locations, and we have a lab in Bangalore too. Okay, thank you. All right. So that's at a higher level, as I mentioned before. We are a company that does engineering services, test solutions, test equipment, and authorized test center for various applications. That includes mobile, that includes UHS-2, SD card, you pretty much name it, we do everything. Plus, we also do product matching services for interoperability, again for various IoT and or consumer applications. Multiple locations worldwide, almost 9 locations. And here in Bangalore, we concentrate again on IoT testing, test automation, as well as custom test automation for multiple test standards. So with that out of the way, I know that the IoT definition is a multiple definitions for IoT. Everybody has their own definition. So this is an attempt to try and standardize what IoT means from a usage viewpoint, right? So the simplest definition is it's a world of heterogeneous things that have identities as well as physical attributes. Physical attributes being something which is obviously seen, something that communicates to some kind of an address, be it wired or be it wireless. Right? That is the essential definition of what we call IoT. And these are seamlessly and securely integrated into the internet infrastructure using standard communication protocols. And in the show, we have been talking about what protocols are being used, what interoperability means, and what standards mean from an IoT viewpoint, right? So everything is tied together with interoperability protocols and communication protocols. And that is why we believe, as in within the industry, that having interoperability due to various test standards will essentially move the IoT infrastructure on the ecosystem from a proof of concept viewpoint to a mass market viewpoint. And that's the next step going forward. So the multiple protocols and standards are supporting are obviously Wi-Fi, Bluetooth, Ethernet, 3G, LTE. We're all aware of those standards, right? But the newer, let's say, standards that are tailored for the constraints of connected things from an interop viewpoint, or Zigbee, Z-Wave, Thread, OCF, etc., as well as 6LoWPAN, RPL, and co-op. So multiple applications. But the key message here is that the market defines what will make IoT succeed. And we have known from past experience that if there's no interoperability between various heterogeneous devices, so a device working in isolation will never succeed. And that defeats the definition of the Internet of Things. They have to talk to each other. So the message is about heterogeneous devices talking to each other with a common framework, which is then defined by a particular standard, which is then based on what kind of solutions they support, either IPv6, 6LoWPAN, 802.14.5, etc., etc. That is pretty much what this slide is all about. There are various segments and markets. Again, this is standard information, but at a higher level, this is what it's been spoken about. We have RFID-based applications, which is obviously at a lower level, already done in most of the Asian as well as European markets. We have machine-to-machine communication and machine-type communication. That's industrial markets, where there's a need for security, there's a need for portability. We'll talk through that. Wireless sensor and actuator networks. Sensors are the majority of IoT components right now. So a watch has multiple sensors, gyroscopes, we have accelerometers. Anything in the consumer side, on the body wearables for that matter, is all about sensors. There's a market for sensor testing, sensor validation, etc., which we will talk about as this slide unfolds, right? And there's what's called ubiquitous computing, which is again self-explanatory, and then web of things. This essentially is anything that's connected to the Ethernet or to the ether using wired or wireless or old peer-to-peer computing. So all of them have to again talk to each other. That's a Web of Things market. This has more to do with the mobile tablet space, where again the question is there a common model that essentially is working for all heterogeneous devices to talk to each other? So I'll keep repeating the word heterogeneous because that's critical. So basically any device that cannot talk to one more device is not IoT device. I think that's the message I'm trying to say. That's why there has to be a common framework. Key vertical segments with some revenue. Automotive, we are all aware of it. As cars get cheaper, the features in them go up. So now every low-end, medium-end, and high-end car has audio, video in terms of feature sets. We all have a display. We all have GPS. We are able to listen to music. We can record. A lot of things going on. So all of these are within the IoT automotive space. And now some of the standards are mentioned, like OCF and Thread, are coming up with automotive-specific standards, right? Which essentially help bring down the cost of IoT from automotive viewpoint. The second point, right? Healthcare, again, anything to do with healthcare has big bucks associated with it. Everybody wants to do IoT within healthcare. We're talking about heart rate measurement. We're talking about blood pressure measurement. Anything to do with the body, which essentially gives doctor or physician data about the wellness of an individual, is again IoT. It's talking to each other. That's a good market. Consumer electronics, again, this is huge, 445 billion by 2020. Consumer electronics is anything in the house. Be it connected home, be it smart metering, be it machine to machine within the smart home, and we're also talking to a large extent about smart fridges and white goods. All of these together make up what we call a consumer electronics. That includes TV, set-top box, etc., etc. Right? And finally, utilities. This is a new market. And there was a lot of talk in this show about smart cities, which essentially is what the utilities are talking about. We're talking about off-grid, where in islands where you have disaster almost every 2 weeks, where we have a typhoon, there's no power associated with it. Then we have off-grid opportunities, where you're using battery as well as solar. And these units then talk to other devices worldwide to make sure they're getting off-grid power. That's an important element. That also becomes a part of IoT, where data is shared. Right? And the key message in this slide is IoT market or IoT implementation generates terabytes of data. What to do with this data, we all know, but how to do it, we don't know. I think that's the message I'm trying to convey here. There is a market for what we call big data management. So we need intelligent data for businesses to make business decisions. And that is the output of any IoT implementation. And I'm sure in the other committee members' meetings tomorrow, you will hear about what to do with data, what to do with secure data, and what companies are doing from a revenue viewpoint with this terabytes of data that's being generated by IoT implementations. Now comes the meat of my talk. What is SD technology and what does it have to do with IoT? You heard about SD technology, but what does it mean to the IoT market, right? So I'm paraphrasing what the previous two gentlemen spoke about earlier. The key IoT market requirements are outlined here, right? Key again is system device interoperability. Again, I'm talking like a broken record. This is critical. Interoperability between devices, between systems is key for the IoT market. That is standards or protocol-based design. So whenever any board designer or system architect is looking through designing from a system viewpoint, hardware and software. Hardware is leverageable, it's common hardware. Software is not leverageable, software is customized, right? So within the software stack, there will be certain layers, which for the application layer and the link layer, which need to adhere to certain standards. And that is where the initial design comes into play to make it interoperable. So we are thinking from the hardware all the way to the software stack. And these are the various standards that I mentioned that talk about it. Right? Second, seamless uninterrupted communication between devices. This is typically wireless. There is some wired for telecom IoT, which we're talking about, but most of the current markets are wireless, using what is called mesh networking. For the connected home, it is, as I said before, 82.15.4. We have Zigbee, we have Z-Wave, we have low-power Bluetooth, and the underlying technology is called 6LoWPAN, using IPv6. That's more on the security side. So That is popular common communication. There's nothing new there. We are aware of that. But that is an important element of seamless transition and seamless communication for the IoT devices. And three, secure accessible data storage in a small footprint. And that is what an SD card is all about. Right? So this essentially will give you, as a perfect fit for all detachable secure storage applications. There is the SD card. And the previous two gentlemen explained to you in detail what's happening there. This is tying that all together. Now I'll take a little bit deeper and talk about IoT hardware design considerations, what an architect is looking to do when you're designing IoT hardware, right? So in certain situations, again, depending on the sector and the segment within the world, we need to make these devices work in extreme conditions from an industrial IoT viewpoint, for that matter, for healthcare, depending on where they are implemented. So devices in this ecosystem will face challenges of extreme temperature, humidity, pressure, shock, vibration, power supply instability, etc. We can't control where these devices go. In the consumer, in the home, it is controllable. Industrial IoT, machine-to-machine, RFID type devices, they can be anywhere. So you cannot control in the environment they work in, right? That's an important element. So we are designing our hardware based on extreme conditions operation. We are designing for frequent read and write operations. That's critical. Otherwise, why have storage if you can't read and write frequently? And that inherently comes with its own problems, which again SD card can take care of. Engineers who design for frequent read and write are used to certain data losses. How do you take care of that is an important element that the SD card will take care of. And finally, long-term product viability. By its very definition, the Internet of Things market is a low-cost market. That's a given, right? Which means bill of material concerns are critical, and that's something that we will talk about as the industry evolves. And then non-industry dynamics also play a major role, because if I am a purchaser for an IoT company and I am tasked with making sure I get the best possible price from a NAND vendor, the key roadmap keeps changing. And my proof of concept is based on a certain technology, and in 6 months something changes, then I'm in trouble. Right? So those kind of scenarios, right, together make up the design considerations for any IoT-based hardware. So again, the key message here is in the IoT system, I call it a system, that's hardware and software. Hardware is leverageable across various verticals. Software is customized. And that's why the Indian market has such a huge advantage, because we are known as software gurus of the world. And that's a huge plus going forward. Again, if there are any questions, please feel free. I'm trying to run as fast as I can, given that we have some more slides. Summarizing what I just spoke about, IoT hardware design needs met by SD card. Right? So we're talking about security. The gentleman before me spoke in depth about what we support from a security viewpoint, an SD card. So digital content security and protection. This is critical. And in fact, in one of the, we had a press conference earlier today. 2 or at least 3 of the reporters, this is the first question they asked. How email hacking is any unit or any RC, any capacitor, resistor, any processor, anything that goes into the board has to be as small as possible to make sure that you're designing it within the small footprint requirement. So this space constraint essentially translates into BOM, and it translates into a lot of issues if it's too big, right? So what that means is this removable small form factor SD card is a best fit for any IoT system design. And then there are options too. You have a full-size SD and a micro SD support. You support both. So in the healthcare segment, the size may not be a factor, right? But we still have a full SD form factor which can be used there. In the body wearable section, probably in some of the industrial IoT markets, size is critical, right? So then micro SD support becomes essential. And again, the gentleman before me spoke in length about what features are available. Again, the message in the first 3 bullets is it's a unique fit, it's secure, it is small form factor, and even more important, is leverageable across various designs with one common hardware and multiple customized software. And finally, reliability. I think we know how reliability translates into different things for different vendors. So our definition from a reliability viewpoint for IoT markets, we're talking about wide storage operating temperature range. Again, industrial IoT, it goes from -10 to 105 junction. Again, depends on the market. For consumer, it's between 0 and 70. But we are talking about wide ranges. And for automotive, it's even worse, right? Automotive, I think you were talking about one defect PPM over multiple read and writes. So it's impossible to keep up with that. So reliability is critical, again from IoT hardware design viewpoint. Error mitigation and detection technologies to improve endurance as well as wear and tear distribution is inherent within an SD card. That's a given, right? And finally, enhanced IC level validation. This is something most companies end up doing. That's something we as GRL do, as well as other companies also take care of. So these design considerations are all met by SD card, either by the SDA Association's standards or by vendors supporting SD cards. And we spoke to Sandisk earlier, and some other vendors will talk about it also. Right? So this summarizes why SD card is critical for IoT hardware and what you can do going forward from a performance, security, and reliability viewpoint. Summarizing everything, multiple form factor options, integrated security, meets data communication needs, strategic roadmap supports vendor BOM requirements, and technology mitigates any reliability concerns. So the 5 key factors for any product manager to write the MRD is mitigated going forward for IoT designs by supporting a detachable, secure mobile storage mechanism, which is an SD card. And that's why it's important that we go through all the features we spoke about earlier and then talk through what more it can do from a roadmap viewpoint with SD 6.0 and the various other features coming forward over the next 2 or 3 years. Any questions, please? Please. Below SD 6.0. So anybody here wants to talk about it? Kaz? Backwards compatibility between SD 6.0 and the previous versions of SD. Right. Okay. Okay. So nothing changes. Right. Only the data rate goes up, which is good for everybody. Right.
No, actually, the technology says that I saw in some of the slide that it is 6.0 is using LVDS, and earlier we were using like single-headed signaling, so that's why I was a little concerned about it.
Good question, but no change. Right. Please.
So the UHS-2 is LVDS, not the UHS-1. So SD 6.0 is more on the performance features. It is applicable for both UHS-1 and UHS-2.
Thank you. Anyone else? Anything about the market? Obviously, you've been looking at the IoT market numbers, so I'm sure you guys have an opinion. Anybody, any questions on that? All right. Thanks again. We are here for the next hour or so. I'll now pass it on to my colleague, Raja Raman.